All right, before we jump into like all of our three-dimensional formulas, I want to run over your two-dimensional formulas real quick because you will need to know them in order to do your three-dimensional formulas. So the reason you will need these is this. Here's a bunch of three-dimensional shapes. When you find surface area and volume, you're going to have to find the area of the bases of each solid. So for instance, if we have a cube, notice it really doesn't matter which of the bases, but just to keep it simple, the top side and the bottom side are the two bases of a cube, and they're actually squares. And then this, if the top and the bottom here are rectangles, notice squares and rectangles are both what we call parallelograms. And there's an area formula to find the area of parallelograms, and that is area equals little b times little h. And the little b is the base of the parallelogram, whether it's a square or a rectangle. Oops, there we go. And then h is the height of the parallelogram. Okay, now if we take both of these, let's take the square, just kind of draw it separately as its own entity, if you will, and a rectangle. Okay, since you're just doing b times h, it doesn't matter really what side is b and what side is h. So we could say this side is the height and this is the base. Same thing with the rectangle. This is the height and this is the base. But since you're multiplying them together, it's really not going to matter which order you do them in. For a triangular prism, or any solid that has a triangular base, or more than one in this case, notice the bases would be this and this in their triangles. So there's another formula for the area of a triangle. Area is 1/2 times little b times little height, or little h, excuse me. Remember, little b is, in this case, it's the base of the triangle. And the little h is the height of the triangle. So if we take the triangle out of its figure and just draw it here, right? A lot of times you're going to have, or you should have, a measurement right here, and that's the height of the triangle. This bottom edge is the base of the triangle. So you're going to do base times height, and then multiply that by 1/2, which is the same as cutting it in half. So base times height, and then divide that by 2. For this trapezoidal prism, you have the base here and then the back one here. And these are both trapezoids. So the area formula for a trapezoid, area equals 1/2 times the height of the triangle times actually the sum of what are the two bases of the trapezoid. And so a lot of times we get confused with what's base 1 and b with the little 2. So we're going to bring it down here, and I'm going to show you that. So first of all, this is the height of the trapezoid. Just going to abbreviate that. This is base 1 of the trapezoid. And this other one is base 2 of the trapezoid. So if we bring a trapezoid down here, okay, just a real simple one. Okay, a lot of times the height will be given here. All right, it's the height from one to the other. Now, B1 and B2, all it means is the two sides here that are parallel to one another. All right, so this one could be our base 1, and this one could be our base 2. So your formula, you're going to take this and add it to this side here, and then multiply it by the height of the trapezoid, and then divide all of that by 2. Lastly, if you have a cylinder, you got the base on top and the base on bottom. They're actually both circles. So the area formula for a circle would actually be pi times the radius of the circle squared. So you're going to do radius, right? R is the radius, and you're going to square it. So hopefully you know, because we've been doing this a lot, if you have a circle, there is what's called a radius, and that's the distance from the edge of the circle to the very center of that circle. So there's your radius. And sometimes you'll actually have a continued line here, and it'll be all of this distance, and it's the diameter of the circle. And notice it's actually exactly 2 times the radius. So sometimes if a problem gives you the diameter of the base, which is a circle, you can actually divide it by 2 to find the radius. So again, you're going to need to use these formulas in order to find the area of a base of a solid that you're looking for, one of these 3D solids. So just a quick refresher on how these work.